Okay, welcome to the 10th late night programming stream. I'm Lucretius or Luca, and we're gonna continue on with making asteroids in C with Raylib. So here's the agenda for today. I did some offline fixes to the game, and they're really small. I'll show them real quick in a second. The first one is that I figured out why the wrapping code wasn't working from last time, and so I fixed that real quick. And the second thing was that I added the wrapping, the drawing functionality again on the asteroids. So the asteroids now like scroll through, like they look like they're scrolling through the screen. Now there's still an issue with the wrapping with them, which I'll explain in a second. But yeah. So after that, after I show these two things, I'm just gonna add a couple sounds, and then I'm gonna do something cool by making the kind of the asteroids like bump off each other. I think that'll be kind of neat. And then we'll try to fix up the asteroid wrapping, and then after this, who knows? Sky's the limit. So let me just first show off what we have right now. So this is how the game looks like, and as you can see, they are scrolling correctly. So as you can see, like this, actually, let's make this a little bit easier to tell. But if we go to, let's say, where are we spawning some of these guys? Somewhere up here. So if we go here, where am I spawning some asteroids? Yeah, right here. So let me actually just spawn one of them, and I'll do that just by making a variable here. Spawned equals false, and then here only if not spawned, and then spawned equals true. Okay, so this should only spawn one asteroid when we compile. So okay, so as you can see, the asteroid is wrapping around the screen very nicely. As you can see, it pops, once it goes off the screen here, it kind of pops from the bottom, which is kind of neat. You can see it's like very smooth in that sense, and that's because I'm actually redrawing this 4 times more than you see here. So I'm redrawing it up here, down here, on the left, on the right, so it looks like it's always so it looks like it's like it's the same asteroid coming from the bottom, even though it's like a copy. And so you can see this is a copy of that asteroid. Like, they're not the same asteroid. And in fact, once this goes off screen, I'm going to try shooting it from the bottom. Well, it'll have to move a little slower, but basically, if I try to shoot it just as it comes up from the bottom, I guess I was too late. But basically, this one down here wouldn't have collision, because the only asteroid that has collision is the one that's being teleported around the screen. So yeah, so that's how the game looks like right now. There's like a little particle system going on here with the thrusters, and I think what I'm going to do is, like, right now it's starting from the middle, so I kind of want to add to the to-do list, like and also if you look closely, if I shoot, the lasers come from the middle of the triangle, and I think it would look better if it came from the tip, like from the tip of the triangle, not the middle. So we're going to add those two things to our to-do list. We'll do that after we make the asteroids bump into it. Make laser and thruster fuel come out of more logical locations, I guess. I don't know. Alright, and now I'll show the offline fixes I did, just so we're all caught up. And if you're watching this as a series, you know what I did to fix the issues from last time. So if we go to, where is it, wrap asteroids, yeah, right here, the issue I was having was that I was right here, I think checking X or Y, X instead of Y here. So one of these is wrong. Basically, I was checking against Y and against X instead of Y, so I fixed that. The other thing I did is I have this draw code here for drawing the asteroids, and when we ended off the video last time to stream, we had all this comment out, and now I just uncommented out, and this is just basically the positions it's like redrawing the asteroid at. So if we go down here into the draw code, here's, you know, iterating through all the asteroids we have. And then here we are iterating through each point of the asteroid. And then here we are iterating through each of the copy positions we wanna draw them at. So yeah, that is basically the offline fixes. And so if we look at our to-do, these are the two things I want to talk about basically real quick. Okay, so I think today we're gonna sort of take it easy, and we're just gonna do some simple fun things to make the game a little bit more enjoyable to play. So one of those things is adding sound, and I actually don't know how to do that yet, and I haven't even bothered looking up sounds for this. So I think we might just make a sound. I think we can do that. And yeah, so I guess I want to see here how to play sounds. So let me see, play sound. Oops. What is sound? Oops, sound. Okay, here we go. So here we could load a wave, load sound. Okay, load sound from a wave. Okay. Update sound buffer with new data. Okay, so this is like to play, this is like to create your own sound, sort of, which is kind of neat. So I think we can use load sound probably. And I know music has like I remember it having an update function that we need to call if we wanted music. Hey, what's up, fan? In my decompiler, is it the same if I just insert a label if I can't find any pattern? Is it a shame if I just insert a label if I can't find any pattern? Like, there are some patterns I don't know how to make into nice C. What do you mean, like, make a label? Like a jump? Like a jump? Somewhere to jump to? Is that what you mean? Yeah, so I think with music, as I was saying, there's like an update. Like there's something that needs to be called every frame for it to... Yeah, I think it's not unload, play music stream, is music playing, update music stream, updates buffer for music streaming. Yeah, it's one of these, but whatever. So we're only gonna add sound effects. Alright, let's see if we can find some free sounds to... or a free sound generator. I think there should be something on itch, maybe on itch we can find like a cool sound generator, something to create like a pew sound, you know, a pew 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 sound effect. Free sound. Actually, you know who might have some? Maybe Kenny. Maybe Kenny has some sounds I could use. Who knows? I'm not sure. These are good assets if you wanna, you know, have something completely for free. So audio, nice. What audios do you have, Kenny? Let's see. There you go. That's what I want. We got some. It's under Creative Commons, so I can just yoink it. Sorry, Kenny. I have donated to Kenny before. I really like his stuff, and I think it's important to support this kind of stuff. It makes game development a lot more fun and easy, and you don't have to worry about stuff. So thank you very much, Kenny. You are a lifesaver. What else is here? All these sounds could be pretty useful. Voiceover pack, music jingles. I guess we could even have like a little music jingle for when we add roguelike elements. Cool. Are these RPG audio? I'm just waiting for this to download. It's taking, I don't know why my internet is so slow. It's probably because I'm streaming at the same time, but I promise my internet speed is not under 100 bits per second. Yeah, just the regular RPG sounds. That's kind of neat. What else is in here? Impact sounds, casino audio. Interesting. UI audio. That might be useful for later. Just like sort of like switch sounds. That's cool. Cool. Are we almost done? Yeah, we're done. Sweet. So let's go ahead and open this, and let's drop this here. Nope, didn't work. So extract. I should learn how to use the command line for extracting files, honestly. Where to go here? Okay, there we go. OGG. Does Raylib open OGG? OGG. OGG. I think OGG is a little slower too, because yeah, you can, because it's compressed. So I guess I'll find out how it works. All right, so let's take a laser sound here. Let's do lasers. Is laser small? Yeah, laser small. There's a couple of these, so let's see how this sounds like. Okay. I like it, this one. What about this one? Another good one. What about this one? It's a good one. I think this one we'll use for like enemies, maybe, when we have enemies. This one as well. This one sounds more like a good guy. Like a good guy, laser sound. I think that's fine. Alright, so let's take lasers. Laser small underscore 1 to our asteroids folder. That's right here. There we go. And now we can go ahead and load it. So the way to load it is just using this here. And so you have to unload it at the end. It's fine. And then to play it, you just do play sound. Okay, that's awesome. Really easy synth API for this. Let's go ahead and do that. So I'm gonna go ahead and let's see, main. Let's go ahead and find, and actually we can just inline it when we load it here. Let's load in the sound. Let's do laser fire. That's gonna be equal to load sound, and this is gonna be, I think it's laser small _001.ogg, and that's literally in this folder. Should be good to go. All right, and what else do we need? I guess this would have to be in the build folder, because this would be run from the build folder, so it'd probably give me like an error or something if it's run from here. So I think what I also want to do real quick is, instead of, I have right now like this make file here, make lists, which sort of makes it so it does the build inside this build folder I created here. So I can remove this build folder. I guess I could just do this and then just have it, you know, it'll create the C make files right in this directory, and then I'll just put all those random things I don't need in my git ignore for now. But yeah, so if I make this, it should make just fine. Cool, and sure, so just making sure it works out fine. Okay, so that's fine. And then I also want to edit my git ignore. Oh, I totally forgot that I didn't properly do my I didn't set up my git properly yet. All right, well, I'm gonna go ahead and just add a bunch of these things into my git ignore. So definitely I need to add the cache here. So cmake cache, cmake cache.txt. I'm gonna add that. Also gonna add anything .cmake. I think I'll add as well. So if it has a .cmake, I'm gonna add it. How's that look now? All right, so we're getting closer. We're gonna remove the make file because that's something that's generated by cmake. And I think that's it. Oh, and we have to remove the cmake files as well. So cmake files. There we go. So I think that should be good to go. All right, so git ignore ignores everything I don't want it to keep track of, which is good. And I'm gonna go ahead and delete this compile script that I had before. I don't need it anymore. And I also need to make sure that I don't commit the executable. So let's put that in here as well. Asteroids. Okay, so there we go. All right, that should be good to go. And now we can make sure we can try playing that sound here. So I also have to unload it. So unload sound. And I think here would be the laser. Here, there we go. There we go. And this should be I'll make this in a second, but right now we're gonna add the sound for when we fire. So where is that location in here? So there's a fire button, and we'll only do it if we actually spawn a bullet. So you will do play sound, laser, fire. All right, let's see how that works. Does that work? Cool. Cool. Did it load it? Okay, nothing's playing. Is there any errors? Sound failed. Okay. Failed to get frame count for frame conversion. Failed to... Data was loaded successfully. Failed to get frame count for format conversion. Failed to create data conversion pipeline. Failed to create buffer. Okay, so... the sound was found. It exists in our file system. It was able to load it. But everything else it was not able to do properly. So... let's actually see if there's anything else I'm forgetting here. No, it's just play sound. Oh, in an audio device. I have to initialize it. Okay, that's probably something important to do as well. So let's do that. Main, and before we even load it, we will initialize audio device. And at the bottom here, we have to do the same thing, I think. And we do it after we unload the sound. So close audio device. All right, so then let's close this, build. All right, did you get any errors? All right, cool. Now we have a little firing sound. That's cool. Neat. All right, let's see if there's a way to dynamically turn down the volume here. So go here and see what options we have for playing sound. So that's load sound, play sound. I get maybe sound has like a decibel set volume on the sound. Okay, there we go. So let's turn this down. Let's turn down the sound. Oops. Let's turn down the sound. So sound, oops. And let's turn it down. So set sound volume. Here. We will set it. This is in decibels. I'm guessing it is. I'm gonna just lower the. I'm just gonna make it. I'm gonna lower it by half, so it should sound half as loud with this. I think. Laser, fire. There we go. And let's do a quick run test. Oops. All right. I don't think I actually ran. I don't think I actually. No, I did. But I feel like it didn't. I think it made it louder. Like this sounds louder to me than fire. So let me check again here. Set volume. Let's check the 1 is the maximum. Oh, so maybe. Oh, okay. Okay, so it's normalized volume. So 0 would be negative infinity decibels, I think. So, yeah. Okay, so how do I go back to the previous file? Go back to previous file. Open. Yeah. Okay, so it's alright, perfect. Cool. So here instead of -3, I should put in, let's do 0.5. That should be half as loud, I guess, right? Is that what it's saying? Is that what it means? Yeah, cool. So this is a little bit nicer. All right, so now the other thing I want to do is I want to add like a little explosion sound for our asteroid. So let's go back into where we've downloaded the audio, And let's see if there's an explosion sound. Thruster fire. How does this sound like? That's kind of cool. That maybe could be used for our like movement in with our little ship. Explosion crunch. That's nice. That's good. That's too much. That's too big. It's too big still. I kind of want something small. I want a small explosion. This was okay, I guess. Except it's still too much. Like, I want it to be like, psh. So I guess I will have to... Do we have Audacity on this? Just so I can lower it? I guess I could just download it real quick. Audacity. People are mad with Audacity because I think they added like some... I think it was some telemetry stuff maybe? I can't remember what it was actually. Alright, so while we wait for that, we're going to go ahead and just link this sound from here, and we're going to put it into our folder. So here's Asteroids, put this down, and we're going to rename this to Explosion. There we go. Now we're going here. Oops. Let's see, and load sounds. We're going to load another one here. So this one will be sound. Explode Astro. Actually, yeah, we'll just call it explode because I think we'll also reuse it for when the player dies. Load sound, and this will be just explode.org. Cool. That should be good to go. And we'll also lower down the volume by half. So let's take that sound and lower it by half. Hey, what's up, C developer? It's good to see you again. It's really good to see you again. Are you working on anything interesting, I mean? You have any cool side projects you're working on the side? Right now I'm just adding an explosion sound to the asteroids. Oh, that's cool. I'll definitely tune in. Cool. What's backend stuff? Cool. I'll definitely tune in whenever you get that up and running. I'm just gonna make sure to follow you so I can be notified whenever you go on. Just see what everyone's up to, you know? Program streams are cool. It's cool to program alongside someone, I guess, who's streaming. That's kind of why I like I don't know if you know who this is, Tsoding, but I watch him a lot, and I really enjoy like coding alongside whenever he goes online. It's just kind of a nice thing. It feels less lonely. Okay. Alright, so when we kill the asteroid, we want to play that sound. So where is it? Where do I destroy the asteroids? Yeah, Tsoding's cool. He's very fun to watch, I think. Yeah, so he focuses, I think, on a lot of different things. Like, he's done languages, he's done like assembly stuff, he's done random like non-game applications. I think my stream will be focused more on like game related things because I like doing games. So we'll probably make like non-game applications, but they will be game related somehow. So it'll maybe like a sprite animator or something like that, which I think will be kind of fun to do. So yeah, that's kind of my goal here. All right, let's see. Alright, so this is when the asteroid dies, so I can just go ahead and play the sound here. Explode. Oh, I think that's all I need, actually. Oops. I did not name that properly. Explode. Oh, something froze. Okay, there we go. Alright. No explosion sound. Did we load it successfully? Yeah, it seems like it was. Oh, you know what we don't do? We don't unload that second sound, but I also don't see the explode sound loaded anywhere. Here's the laser sound. We've just loaded that. but it doesn't load the explosion sound for some reason. Okay, so let's fix that real quick. Alright, let's see, main. I wonder what's happening here. Well, okay. I have to make sure to unload it, so let's do that as well here before I forget. And I guess before I set this, I want to make sure it's playing, so I don't want to do anything else. And it's called explosion.ogg. Okay, not explode. Explode. Okay, so let's do this. Explode. I'm going to focus on C and the little more advanced than most of what I've seen on Twitch. The C primers will understand what I'm doing. Python programs will have a hard time. Cool. That sounds fun. That sounds pretty cool. Very nice. So now we have the explosion sound on the asteroids. So that's pretty neat. That's cool. Alright, so we're playing explode here, and I guess I could also make sure to turn this off. Make sure it's a little quieter. Have we finished downloading Audacity? And we have. Okay, good. So let's do this. Open with... Did I download the wrong thing? I literally just clicked the first thing that I found. App image. I don't know what that is. You know what? I'm pretty sure I can just get it on. Pretty sure I can just get it on through our package manager. I think sudo apt-get install Audacity, and I think I can. Yeah. So I'll just wait until that downloads. That should be okay. Alright, ooh, Audacity. Nice. Perfect, that's what I want. And now we will go ahead and let's put our explosion sound in here. And we're not gonna make it that loud. We're gonna cut off, let's do all that. Make it only 0.2 seconds. And we'll make sure it's faded out. So let's go here and fade out. That's too much. I guess I could fade out from here and see how it sounds. Let's delete this here. And fade out again. Okay, that sounds fine. Sweet. Let's cancel that, whoops. And we will export as OGG in home dev asteroids explosion. There we go. And quality, sure, let's keep it at 10. Alright, that should overwrite. It's fine. Okay, don't care. Alright. Nope, don't care, don't care. Alright, perfect. So now when we run this, it should... Alright, yeah, so it's a little bit shorter of an explosion sound. I don't think my decompiler will be perfect, but if it's at least better than assembly, isn't it still a win? Oh, dude, of course. Yeah. It's really, I think it's like, I mean, reading assembly is not like a useless thing to do. Like it's a really important thing to do if you ever do low-level programming. But if you can make it simpler for yourself to understand it, I think that's a win for sure, 100%. Honestly, just even coding like a decompiler just for the sake of it is like a win on its own. So I think that's cool. All right. So now that we've done those two things, we've added 2 sounds. Let's go ahead and add a pause. Pause seems kind of cool. And we'll even have like a mini pause screen. So pausing is usually if you're, this, I don't know if this is too loud for stream, the music, but it seems like it. Alright, I turned it down. I hope it wasn't too loud before. Alright. Reading assembly for smaller functions is fine, but if there's thousands of lines of assembly with a lot of branching, I don't want to. 100%, yeah. Totally. Again, reading assembly is something that if you really get into low-level program, is something you'll have to learn to do. And it's not like something you'll have to do all the time, but it's good to, like, writing a decompiler is like a really good way of like understanding assembly at a good fundamental level. So I think that's a good like project no matter what. And the fact that it, you know, makes it easier to read is like also a win on its own. So yeah. Why is this music so loud in my ears? Let me turn this. Okay, so turn this up and then turn this down. Alright. I don't know. The music sounds loud to me, but I don't know how that sounds to the stream, so I turned it down. And if there's no music, I guess there's no music. Alright. Let's see. So I want to make a pause screen. So usually if you work on games and you're working with a game engine or something, doing a pause is kind of annoying and hard. But when you write your own game engine, it's actually one of the easier things to do. So really we just have to put anything that we don't want to run while things are paused, we just have to put under like an if statement. So it's really not that bad. So something I want to do real quick before I do that is I want to make a new function here. And I want to call this simulate game. Alright, let's call this simulate game. Or just simulate. And this was gonna run our most of our logic here. So all this basically, everything inside this giant loop, we're just gonna move in there, and that'll just make it simpler to do what I want to do. So take all this, and actually we want to keep the drawing here, so we will just move it here. We'll do this. So let's take all this, nice, and we will move it up here. And this will be called every frame. So now we have to fix a few things. So let's put this back here. I wonder how slow my code will be. I think it'll be fine, dude. Alright, so now we will go up here, the beginning of this function, and we need to, yeah, so we'll need to add in the properties for the game. So to do that, I think I'm gonna have a game structure that just kind of holds everything I want. And this will contain, you know, this will contain the player. This will contain, what else could this contain? Actually, this is the wrong way around. This is type def of struct. And this will contain, what else? Well, let's go through the errors one by one. So we need this. So is player moving is false. Okay. And here what we can do is we can set the player as the game player like that. Let's do that. And instead of player dot, we now have to do that. And that should be okay. So we have to go through all these. So for all these, we have to do this. There we go. That's okay. That's good. And asteroid spawn sec. Let's put that in our game structure. Asteroid spawn sec. Go. And we'll set this outside the simulate loop. So here we go. Do that. Game asteroid spawn sec. And this is actually that. Okay. We actually don't need this anymore. Not spawn, because we want to spawn not a normal amount of them. So do that, do that, do that, do that. Okay. Laser fire. So for that, we're actually going to create some global variables here for our sound. So laser fire will be here, and our explode sound will be also declared out here. And we'll set those before our simulate loop. So let's keep going. So player, this all has to be converted into a pointer. Yeah, I have to do, I moved everything into a function, and when I do that, I have to, you know, go through every pointer, non-pointer, and make it into a pointer. I know there are some languages like Odin where you don't have to do that. And like you can just use the dot for both accessing a pointer field and accessing like a structure field. And I think that's kind of nice. Alright, so thruster interval sec. I think for that we will keep that outside of here. So thruster interval sec. Interval sec. We'll set that outside the loop as well. Alright, so that's good. And then we have a few more that we have to change here. So let's do that there. That there. That there. You don't have to take the pointer now, we just slide in the player. Score. Okay, score is a good one that we could keep as a global variable. Or actually, let's keep it in the game. Let's keep it in the game struct. There we go. So now it's in the game struct. That's okay. So score. Where'd you go, score? Score. Alright. What else is there? I think we're almost done. Alright, player. Have to change this one. It's game over. We'll leave that there because we do need it. And we'll still need it. We will keep it so our player can't die yet, because I think that's useful. And then we will return this. We will return game over. So if there's a game over, this will return true. Alright. So I think that does it. The only thing I have to do is I have to move the definition of the thruster interval. So thruster. So I think this here, I have to move this up. So let's take this. Oh, it is set before this, so it should be fine. I don't know why it's giving me. What's it saying? Float to int. Ah, float. Okay, there we go. Alright, and then down here, we can remove this. Is player moving? We don't need this. We will create our new game structure. And instead of initializing the player like this, we will initialize it within our game structure. So, there we go. And our game structure has a score, so that's done there. So it's dot. Alright. Okay, I think that's good. Drop player. We will name layer. There we go. And here as well. Dot. Cool. And instead of loading our sounds into local variables, we would load them into our global variables. So I think that should be, we're getting closer to finishing this like mini refactor. And now we actually have to call simulate here. So that game over is equal to simulate, and we'll put our game. And if game over, we will return. We'll break out of this loop. All right. Let's see if this builds. Alright, build, it plays, and we're spawning a bunch of asteroids. Okay. Alright, we get explosions. I can move around. Alright, so the refactor, I think, went fine. So something else I need to do is I want to re-add the ability to break up asteroids. So let's do that real quick. Thanks, C developer Prog. Fan's problem is like very interesting, I think. Or what he's trying to solve, I think. He's like trying to do like he's trying to do Pokemon mods, I think. Is that it? Is that what you're like working on, Fan? Alright, let's see. Now I want to do, yeah, the asteroid thing. So let's go to our asteroid. Yeah, our asteroid thing here. And we do need an isBig variable for this. So we need to tell if we're destroying a big asteroid or a small one. Alright, so when we spawn one, spawn asteroid. When we spawn one, we'll just set the isBig field to whatever's passed in, and that should be good enough. IsBig is equal to isBig. And then I think we have like a false and. Not there. Where do we do our check for if it's a big particle? Right here. Perfect. So here we'll do asteroid is big. There we go. So this should make it so when we destroy a big asteroid, it spawns 4 small asteroids. Okay, so totally forgot what I was gonna do. Oh yeah, I wanted to test the asteroids if the big ones break into small ones. Yeah, there we go. We have asteroids that break. They break into small ones. That's cool. And they kind of look like asteroids too, which is neat. Alright, let's add our pause button. Oops. Alright, let's see. Let's add pause. We create a, yeah, pause. Here we go. So all we have to do now is we only care about pausing this here. So if pause, let's call this paused. If paused, all we have to do is just not run the code. So as long as it's not paused, we run this code pretty much. I think that's a good way of doing it. And if it is paused, we will draw player, whatever, all that. But if paused, we'll also draw a text. Saying, you know, we're paused. So let's do that. Paused. And this will be get screen width minus text width divided by 2. And then we will do get screen height minus whatever we do the text height with. So let's do text size here. Let's make this 64. That seems like a good size. It is going to be minus text size divided by 2. So it's right in the middle. And then we will do the font size, which is the text size we just said, and we'll keep it red. The other thing we have to get is the text width, so let's do that real quick. So text width is going to be measure text, and this will take in our paused thing. And the font size is text size. There we go. So that should put paused right in the middle as long as we are in the pause state. And now we just have to have a control do this. So let's do this before we even simulate the game. So get key pressed, or is key pressed. Let's do is key pressed. That's better. So is key pressed. Let's do P key. PP. All right, and here all we have to do is paused is equal to not paused. There we go. So this should make it so we can pause our game now. Let's give it a shot. So here we're moving around, whatever, and then P. Oh, paused is not in the right place at all. But it does work, it is pausing, and then when we turn back on when we press P again, we're good to go. Alright, so let's fix that paused issue. I don't know why it's showing up down there. So let's fix the pause button. Let's see. Why am I drawing this incorrectly? So it's because this is not divided by 2. So let's divide that by 2 and divide that by 2. Alright, let's build. Alright, so now we have a pause button. Nice. I kind of like the retro look to this. I think it's kind of cool. Cool. Alright, so now we have a pause button. You can go ahead, go into our to-do list, and we can remove this. Actual game over. Something I just thought of is that we can do slow-mo pretty easily, I think. I haven't tried this yet, but I think we can do it really easily in our program in the way it is now. So all I need to do is write one function. So let's go to our simulate function here, and right above it we're going to create a new function here, and it's going to be called get. Instead of frame time, let's do get my frame time. I think this is a little better for that. And we will also create a scalar here. Time scalar. Time, or yeah, let's do time factor. Like that. And let's do it at, let's leave it at, 0.1 right now. So 1.0, so there's no time factor. And then here we return get frame time times time factor. All right. And now we have to go through every single time we use get frame time and change it to get my frame time. So get frame time. Let's go through that. So get my frame time. All right. Oops. Get my frame time. Get time. Get my frame time. Get my frame time. Keep that in the middle. Get my frame time. Get my time. There we go. So that's every single time we use get frame time, we actually route it through get my frame time. So this should work exactly the same as before, except for that, because I added a double parentheses. So let's fix that real quick. There we go. So this should work exactly as before. Nothing changed. But now we have a way to slow things down. So let's play around with that. So inside of main, inside of the loop, let's make it so when we press a button, we scale down the time. So let's do is key press, let's do key S, and here we'll do time factor is equal to, let's say, if the time factor is already less than 0.9, so if it's not 1, then we'll set it back to 1. Otherwise, we will half it. Let's see if this works. I think this should work. This should make it so everything runs half as slow when I press S. So let's do that. As you can see, everything runs a little bit slower, and then let's actually make it more dramatic, just so it's more noticeable on stream. So let's do time factor Where am I setting it here? So instead of 0.5, let's put it at 0.1, just to make it super duper slow motion. All right, and now, as you can see, I'm shooting around, whatever. And if I press S, everything moves way slower, which is cool. Little slow motion effect, really easy to do. The only thing that isn't slowed is the rotation on the mouse, because that's just updated immediately. There's no like time between like the ship needs to rotate. This is cool. This is really neat. You can just boop, slow motion. Whoa. Slow motion. Maybe we'll make that like a power up in the roguelike. How about making a conf file for these parameters? It's a really good idea. I don't know if I'll do that today, but it's definitely something that I will write down in my to-do notes here for next time. Let's do config file for some setup properties. For now, there's not really much to set up, but yeah, I think that'll be good for example, setting the speed of the player and all that kind of stuff. I think it'll be kind of nice to do that there. Question: in a decompiler, do you prefer all variables used are declared at the top, or declared the first scope they appear in, or the first scope that can reach all? It's easy to guess. What about a help screen for keystrokes? Yeah, that's a good idea as well. I don't know if I'll do it today. I don't think I will actually, but it is a good idea to do that. Let's do a tutorial screen. Right now, I'm still kind of like testing stuff out, so like I'm still kind of working on like the base foundational game. So yeah. Actually, I totally forgot to change the switch stream. It's supposed to be Raylib 3 is the third session, so let's change that real quick. All right, so we added a slow motion thing, which is very easy and very fast. That was kind of cool. That was a cool little trick we can use. And this is something that's actually kind of difficult to do properly in game engines, which is kind of funny given that they solve a lot of other problems, but solving slow motion on its own was really easy in our case. All right, so let's do an actual game over screen. That should also be pretty easy because we already have like a pause set up. So what I want to do is we have a lot of we have a little setup here, and I guess what I want to do is create a function that sets up our game state, because we have to reset that game state. Like we'll have to remove all the asteroids, and we'll have to so we'll have to remove all the asteroids, we'll have to remove all the particles and everything just to restart everything. So let's create an init game function here. Game, and here we'll just move this stuff in for now in here. This could stay outside because that's actually what's being used. There we go. And in here we will initialize the game stuff. So we could probably even put the asteroids inside the game struct, but I'll probably do that offline. When you remove the asteroids, are you going to have them explode as they got shot? When I remove the asteroids, are you going to have them explode as... Oh, that's a fun idea. I think I will do that. That's a pretty fun idea. Yeah, why not? I think I will do it that way. That seems kind of fun on a game over, yeah. Yeah, that would be kind of fun to do. I kind of like that idea. I think I will do that. Yeah, especially because there might be like a bunch of asteroids on the screen. It just might be like a... Yeah, that's cool. I think I will do that. That sounds pretty fun to do. So, init game. So now we have to actually go through all the... I guess we're actually done with this here. We'll call init game. We'll have another function here, which is destroy asteroids. There we go. And then here we'll just go through the asteroid list and destroy them all in the same way and add an explosion to them. So let's do that. It's kind of cool. It's kind of a fun idea. Let's do the asteroid count. And let's open that guy up. Alright, so where do we have the explode functionality? I think that's, yeah, here. So when we reclaim the asteroid, right now here's where we do the explosion on the asteroid. So I think what we can do is move this into a function, probably. So let's do that real quick first. So let's call this destroy asteroid. Just asteroid. And here we will put in the index of the asteroid, which is J right now. And then all this will go inside this function here that we draw. So destroy asteroid, we'll put it right above here. Destroy asteroid, we'll put in the index, which is right there. Alright, and now let's look for it. Destroy asteroid. Oops. Why is this wrong? What's wrong with this? Conflicting types for destroy asteroid? Really? Destroy asteroid. What's it say here? Well, for now, I'm just gonna go ahead and move all of this into our destroy asteroid function. There we go. So that should pretty much do it. Let me reclaim I, and we also need to actually get the asteroid. So asteroid E asteroid, and that's equal to asteroids here. Not sure why I'm getting this. Destroy asteroid. Why is this wrong? Conflicting types or destroy asteroid. What am I doing wrong with this here? Can I name it? What happens if I name it something else? Asteroid. Destroyed. Does that have an error? It does not. Is there more destroy asteroids around here? Destroy asteroid. Huh. Okay, well, if I call asteroid destroy, does that cause an issue? How's this an implicit declaration? And also, why is it taking me to this one? I think the LSP is like fucked up right now. Asteroid destroy. That's so weird that happens. Conflicting types. Make it static. That's weird. That's weird. Destroy asteroid. And I will go down to asteroid destroy. And what's J, I guess? J is a size T. Okay, that's why. So destroy asteroid. We will change this to size T, I guess. If that's what you want, that's what you'll get. Alright, let's see what happens if I try to make non-static declaration. Destroy asteroid, implicit destroy asteroid. Let's see, what's wrong with this? In simulate, implicit declaration of destroy asteroid. Did you mean destroy asteroids? No. Destroy. Static declaration follows non Static declaration of destroy asteroid follows non-static declaration. Previous implicit declaration. Oh, okay. 1 second. So I'm guessing that, yeah, so it's because I'm defining that destroy. I think it's because I'm defining it below asteroids. Yeah, it's because I'm defining it down here and not above. That was a dumb mistake. So let's move that over to above simulate. So simulates here, and I will move that to wherever our asteroids are being set. So here's draw asteroids, and there we go. We'll just add that there. So static, and we'll make this static. All these can be static. Just good practice to add that in, I think. Static. And okay, so here we will just put a little comment to say, is this really asteroids? There we go. And up here as well, let's do that. Let's just, here's where we're defining our bullets to keep it a little bit leaner, and I can see much faster what we're doing. And here's our play. Okay. And static. Static. Let's do that here. Static. Static, that's fine. Bullets. Here's our bullet system. Asteroids. Done that. Alright. Oh, okay. Oh, okay, so this has to actually be done after we do our stuff with our particles. So let's put that here. Have a good night, C developer. It was good having you by. Hope you're able to make it to then tomorrow night, I guess. Yeah, take it easy, man. Always good to have you around in chat. All right, so that's static. All right, so that's good to go. Static. Okay. So now we can just call destroy asteroid, and we'll pass in I. And this could be a size too. There we go. All right, so now we will, if we get a game over, instead of destroying the entire game, we are actually just going to pause it. So here we will do, if it's not paused and it's not a game over, we'll do this. We actually have to keep this up here. Game over equals false. There we go. There we go. All right. And now, when we have a game over, we'll simply destroy asteroids. There we go. So that should do it. And then I think down here we have a destroy asteroid thing. So for now, no game over will ever happen because you can't die. We'll make this. We'll run. Alright, so that still works. Alright, so that's working fine. And now we will make it so when you die, let's go simulate. When you die, we will, well, we'll add that back in because now you can actually die. So player hit asteroid. Yeah, I think we'll do that now. And I guess now we'll see how it looks like. I think we actually don't want to. I think we actually don't want to do it this way. We want to actually keep the game unpaused during a game over, just so we can see the explosions. So that seems fine to me. And we'll also make it so you can only pause if there's not a game over. So you can only pause if there's no game over. Okay, so, and I also want to add a game over screen. So instead of this breaking here because of that, yeah, instead of breaking on a game over, we will instead draw something. So if game over, there we go. And we'll draw it on top of here. We will do the same thing. So in text size, equal to 64. Maybe we'll put this in a define later on. And text width, measure text, game over. R2 start. There we go. Let's do that. And we'll put this in a nice little variable. Text, and let's copy this over. So this will be, oops, why does it do that? It's super annoying. Alright, just copy that and you make it here. Cool. Put that here, game over text. Game over text. There we go. And now we can draw it. So draw text. Game over text. Okay, get screen width. Text width. Gotta get 2 as well. Get screen height. Minus text below. Text size and red. There we go. I think that about does it. And this needs a text size. So when we get hit by something, we should get a game over now, and everything should explode. Let's try it. So let's see. Let's get hit by this guy here. Okay, so we didn't get a game over, but a bunch of things did explode. Let's see if we can get that to happen again. Oh, I guess we have to remove the player. That's cool. But the game over screen doesn't come up. That's neat. Okay, so let's actually fix this. So we actually need to asteroid spawn sec. That's fine. I think we have to not spawn asteroids if there's not a game over. If there's a game over, we stop spawning them. So let's actually move this out completely outside here. So game over will be a global variable like that. So let's see what I'm using game over. So game over is equal to true. And in here, what we'll do, I think what we'll do is we'll just stop drawing the player, and we'll stop allowing you to do anything with their input. So let's do that real quick. So update player. So we're going to just stop the player from moving and doing anything. So if game over, or if not game over, we are not gonna allow any player interactions. And then down here, if there's a game over, we will not draw the player. So as long as there's not a game over, we won't draw the player. So that should make the player disappear when... That should make the player disappear when they get hit by something. So let's see if that works. Let's see. Hit me with something, guys. Hit me with something. Game over. And now I think stuff is still spawning and just exploding on the fly because there's a game over, which is kind of cool. It looks like there's fireworks, which is kind of funny. It's just because the asteroids are spawning and immediately dying. That's fucking funny. Alright, let's make the game over text smaller. So this has to be, instead of 64, let's do 32. Let's see how that looks. Alright, let's see. Let's bump into this guy. Alright, nice. So R to restart. Nothing happens when you press R. Yep. So that's not available yet, that functionality. So the other thing I want to do is I want to know why I'm actually still spawning things in here. So right here. So if not game over, right now we're just, everything's gonna have this not game over thing. We'll refactor this another time where we'll simulate the asteroids and the player and the bullets and the particles in different functions, and then we can more easily pick and choose what we want to be affected by the game over flag. But for now, we're just going to hard code it in wherever we want it to do stuff. So let's make that again, and there we go. So now if I die, nothing should spawn. Let's do that. Cool. So nothing's spawning now, nothing's happening, and I should now be able to reinitialize the game. So now that we're in a game over state, we can now write a little input thing here to restart. So if we're in the game over and is key pressed, and the key is pressed key R, we will go ahead and set game over to false, and then we will do, what will we do? We will do game init. So game init game, and I think that's actually all we need to do to restart the game. Let me see. I think that's it. Set the game over flag to false, and then reinitialize the game, and then this should put the player in the right place, I think. Man, this is like actually broken. Like when I go to definition of game, it goes to pause, which is not it. All right. So here init player, yeah, so here we set it to the right position, which is ends up being 400 and 300, but it's actually screen width divided by 2. We can fix this now and get screen height. Okay, so that should do it. Let's see. Interesting. Okay, so now we have the player starts here. And let's get hit by something. Cool, that works. And now if we press R, everything restarts. Alright, so there we go. So that's working. Die again. Restart. Oops. And if we die, let's hit something. We die. And if we press R, we reset our score. Okay, cool. Yeah, so the reason a bunch of asteroids spawn again as soon as I press R is because the timer is running behind the scenes, the asteroid spawn timer. So the more I wait, the more time builds up, so the more seconds for asteroids to build. So if I press R now, a bunch of asteroids should spawn like every frame for like 10 seconds. Yeah. So cool. This is cool. There's something weird that happens. Like if I start it right away, I just die immediately, which is interesting. So I wonder why that is. I think it's probably because we we call this init game before we initialize the window. So let's actually move that after we initialize the window. So let's move that here. So here the player should automatically spawn in the middle of the screen. So let's do that. And there we go. And if I die, then we get game over. Press R to restart. R, and we get another. Alright, sweet. Alright, so we just implemented our game over screen. But now we can take that off our... Alright, so asteroids bump into each other. Hey, this will probably spend the last hour doing. Asteroids bump into each other, so this is going to be tough to do. Alright, so I guess let's see what options we have for doing that with a Braylib. So let's see. Let's see. So Raylib has these check collisions and checkpoint. I think we'll probably have to do... Yeah, I think we'll probably have to do the lines intersection, this one. We have to check if basically any of the edges on one of the asteroids is intersecting with any of the edges on the other asteroid. So I think we could do that pretty easily. And then what we'll do to separate them is that we'll just get their we'll get their the size they're on and just push them away from each other. So let's do that. We'll push them in opposite direction from each other. Yeah. Okay, so let's do that real quick. So this will be done during our asteroids update. So let's go to here. Let's go to simulate. And there is an asteroid. So let's put this under if not game over. So that way not a bunch of asteroids spawn after that. Actually, during our game reset, maybe we can just reset the asteroid timer ourselves. Maybe we can do that instead. But where is that actually? Asteroid spawn set. Okay, yeah, so instead of I think in init games, because we don't actually, yeah, so here we actually should set that value. So asteroid spawn sec, that's going to be equal to asteroid spawn sec. There we go. So that should make sure that we don't spawn a bunch of asteroids after waiting a bit. That's a nice little quick fix. And now let's do asteroids bumping into each other. So where can we do that? Let's do this during, that's the player update. That's where I'm spawning asteroids. All right, so let's do it here. So we have to do another loop here, and this will happen, I think, after we, yeah, this will happen after we calculate the position after the velocity. So let's do that. So for size tj is equal to 0, j less than asteroid count plus j. All right, let's get the let's skip if j is equal to I. We actually don't want to check for collisions there, so we'll continue there. And now we will get the other asteroid. So other asteroid will be named other, and this will just be asteroids plus J. All right, so now we have to check if there's any intersection at all with this other asteroid. So to do that, we have to check if any of our lines intersect with any of the lines for this asteroid. So we'll have to go through the list of points in asteroid 1. So I'm just going to call this P1 because it'll represent the first asteroid. P1 is less than asteroid point count, and we'll do that -1 because we actually need to get the edges. So that's P1. And then we have to check if any of those, then we'll get a little, I guess, a line here. So the line will be, I guess we'll set up the line in the next for group. So then we'll do P2. We'll do that. P2 less than other point count -1, and then we'll do plus P2. Okay, so in here we will now check for those collisions. So collision check the middle, check collision lines, and the start for it will be, let's actually do them here. We'll call this vector 2 A1. This will be asteroid points P1, and vector 2 A2 or V1. This will be asteroid points P1 plus 1, and that's will always be available because we're minusing 1 there. And here we will do vector 2 A2. Will be asteroid points P2, and we'll do vector 2 B2 asteroid points P2. All right, and then here we have to do the start position for A1 and position for that one there, and we'll do A2 B2, and then the collision point, we actually don't care about it. I'm wondering if I could just put null here. All right, and let's actually check the definition for this. Oh, we can't. It's annoying. All right, so let's... What happened here? What happened there? Oh my god, that's really annoying. Okay, A1, B1, A2, B2. No. Is this possible? Can we do this? Is this allowed? Let's check. So save that. All right, it returns collision point by references. Okay, so I actually don't know if I can leave that at 0. So check collision lines. All right, so I actually don't know if I can set that to 0. So I guess I will just make a vector out here, which will be the collision point. And I think we'll use the collision point as a way to tell like which way we should move away from this guy. So collision point. There we go. And now I want to do who is colliding. Okay. Now if we are colliding, then I want to actually set the velocity of this asteroid up here to be the opposite direction. So let's actually do this, I guess, before we set the velocity then. So let's move this down here instead. I think that'll be okay. This means it's possible for it to move into an asteroid, and in the next frame we actually change the velocity. So I think that's okay though. So if we're colliding, then we're going to get the relative vector from the point of collision to the asteroid position. So let's do that. So that would be vector 2 subtract collision point, and I wanna put the position of the asteroid here. So this will give us a vector that should point towards the collision point when we actually want it to be the opposite way. So let's do that. Actually, asteroid position, and here collision point. So this will give us a vector from the collision point to the position of the asteroid. Then we're going to normalize this, so let's do that real quick. Normalize, that will give us a direction. Directive, right there, right? And then after that, we will actually set the velocity to this direction. So let's take the velocity of our asteroid. Asteroid velocity. And we're actually going to take its length. Actually, we're going to just get its length outright. So let's get a float. Length. Right? So now we got the magnitude of the velocity. Call that speed, I guess. And then what we'll do is we will set the asteroid velocity to be equal to vector 2 scale, and it will be the direction of what we just calculated with the relative vector, and it'll be with the same speed it had before. So this should push it away from whatever it bumps into, I think. So let's see. This should push it away. So let's make, and let's see how it looks. Okay, so it's sort of working. Let's see. Let's see it bump into something. So that doesn't work at all. That's interesting. It's really interesting that it's just very clearly not working. And they're all congregating to like the corners of the screen, which is really interesting. Huh. Alright, so what's going on with that? So let's go to the check collision lines. Okay, let's see, what were we doing wrong here? So this should be okay. Asteroid points. Other. There we go. It should be other. Okay, so let's try this now. See how that looks. Okay, so we have a little, all right, see you bump into something. I wonder why it does that. It's sort of all moving in the same direction. That's really interesting. That it just doesn't work at all. Alright. Let's see. Check collision lines. Okay. So B1, B2, this should be fine. Collision point. I guess the collision point isn't what really matters. So let's, instead of doing the collision point, we will do the other's position. So we'll move into the, and so this will get us a vector between the, so guess what, just from other to asteroid to the current asteroid. Then we will normalize that, and then we will take the speed of the velocity, and we'll set it to move the opposite direction. So let's see if that works. It really does not work. Huh. Interesting. Oh, I know what it is. Oh, I totally know what this is. So actually, check collision line. So these points here are relative to the position of the asteroid. So I actually need to do something like this. Like that. Do the same thing here. And have to do the same thing with these guys, except I have to add others position to this. So let's do that. Other position. And this is add. And vector 2, add other points. I think that's a little better. And I also want to try using the collision point as well again here. Now that we solved that issue, just so we can change one thing at a time. So let's see how that looks. Okay, so far so good. See these two bump. Okay, cool. Those didn't bump properly. But I guess... Okay, those did bump. Interesting. Interesting. It is kind of working. Let me try again. See how it looks like. So those bounced off. That was good. Those bounced off. So they are balancing into each other. Some of them I think miss. But they are bumping into each other, which is cool. Try again. They are bumping into each other. I guess they just mess up sometimes because there might be too many collisions going on. There's nowhere else for them to move, but it is like literally working. Like they're bumping into each other. Look at this. That's cool. That's neat. Just little asteroids bumping into each other. Neat. That's cool. That's really cool. Just watch this for a second and see how it goes. Like it like works really like surprisingly well, actually, now that I look at it. Now that I see it like in action. Like it works. That was really easy to do too. Wow. It's such a simple like algorithm too. That's so cool. They're all bumping into each other. Look at that. They're all literally like bumping into each other. That's so cool. They don't bump into each other well, but like they bump into each other. Cool. All right, so now we can open up our to-do list and take one more item off. So actual game over, that's good. This is done. Okay, so now we can make the laser and thruster fuel come out more from logical positions. Okay, that should be pretty easy to do. This should be easy peasy lemon squeezy to do. So let's do that. Let's do that. Alright, so where are our lasers coming out of? Where are we spawning them from? So spawn bullet, let's see. Spawn bullet. Okay, so that's when we press this button. And how big is the player actually? Draw player. The player is... So the top of the player is up 10 pixels. So let's actually put this in a define. This is... I guess this would be the height, right? Okay. And now when we spawn bullet, we will spawn it at the player's position, at the player's tip position. So that will be, yeah, so player direction. I see. So all we actually have to do, this is actually kind of nice. We don't have to do much here. All we have to do is add 10 to this position. So this will be vector 2 add, and then we will take the direction player dir, and we'll actually scale this by the player height. I think that's it. That should do it. That should... that should spawn the bullets from the player's tip. So let's do that. And it does not spawn it from the tip at all. So let's see why that happens. I did build it. Did I build it? I don't think I built it. So let me try that again. Okay, yeah, there we go. It does work. Perfect. So now the bullet is being spawned from the tip of the player's, not from the inside, which is nice. That's good. That's good. Cool. Alright. So now that we have that, we'll do the same thing with the thrusters. So that will be... I'll still be in simulate. So simulate, we have our... Where's the thruster for the... Oh, simulate's here. So where's the thruster? Let's see. Yeah, so here's where we're adding the thrusters. Here's where we're spawning them right here. And all we have to do is actually take the player direction and now just do it from behind. So here's the position. All we have to do is that same thing, except we do it the opposite way. So player position times vector 2 scale, and I think this is player direction, and then we'll do minus player height, like that. So now this should spawn it from the thrust from the back of the player. Yeah, there we go. That was really easy to do. I should have done that sooner. But it looks way better this way, I think. Doesn't look like it's starting from the middle now. That looks really nice, actually. Alright, game over. Alright, so I guess the next thing we have to do is the wrapping. The damn wrapping. So let's go through what to do. So the next thing to do is asteroids, make the asteroid wrapping better, which means I wanted them to enter the screen fully before they are teleported somewhere else. So okay, so let's try some solution. Let's just start writing code and see where it could take us. So I have an idea of maybe how we can do this. So let's go to our asteroid stuff here. Let's escape, but as entered screen. And then when we spawn asteroid, if it's off screen, we give it the so if X or Y is off screen, we have to give it the asteroid the off screen. This has to be set to false. So this is going to be equal to false, true for now, but then we'll check if X is less than 0 or X is greater than get screen height or get screen width, or Y is less than 0 or Y is greater than get screen height. Then we will do asteroid has entered screen is equal to false. Okay. Why is this getting an error? Between pointer. Oh, oops. There we go. Alright, so if we're not entered the screen, then we have to do a bunch of different things. So here in the wrap asteroid section, we're actually not going to wrap it. So if asteroid has entered screen, has not entered screen, we're actually going to return right away, because we don't want to wrap the asteroid just yet. And when we're drawing the asteroids, we actually only want to draw this first position here. So what we can do is, let's set the size here. Actually, yeah, let's set the size here. Copy. count. And this will be this. So let's copy this guy. There we go. And down here we do copy count. And then what we can do is if no, actually we have to do it on the fly, I think. So let's actually go back here. And we have to do it here, I think. So yeah, copy count, we have to actually set it here instead of up there. So let's do that. Cool. Set that there. And here we do copy count. And then when we check the asteroid here, if asteroid has entered screen, if it's not entered the screen, we will not draw the other copies. So this will draw only the original copy if we haven't entered the screen yet. Okay, and now we have to see when we enter the screen, and when we has to be when we enter the screen completely. So it has to be where the point, the asteroid point, is inside the screen, and it's also none of the edges are touching the outside of the screen. So we're gonna have to check those two things. So let's do that. Let's go into where we do our simulate, which is right here, and when we update the asteroids, we can do the inside, are we inside the screen check. So let's do that here. After we set the position, we can check. So let's do if, put in the middle, asteroid has entered screen. So if we're not haven't entered the screen, then we have to do a bunch of checks. So first we have to check if the asteroid is inside the current rectangle. So if the asteroid has I guess it would be, let's get the rectangle for the screen. So I guess we'll get that before we do anything. We'll do it at the top of the simulation here before we do anything here. And we'll do a rectangle. We'll call this screen rectangle. And here we will do 0, 0, get screen width, get screen height. Okay. So that's good. So let's go back to update asteroids. Asteroid update. So asteroid update, yeah, there we go. So let's go back here, and now we can do these checks. So first we have to check if the position is inside the square. So if asteroid, we have to do check collision, what is it, point rect? Point rect. We check the collision of the asteroid is inside the screen rectangle. And if it is, then we have to do another check here. And then we have to do a for loop to check if any of the edges of the edges touching edges, sorry, one sec, intersect screen right. False. Okay, so then we have to check if any of the edges on the asteroid intersects with any of the edges of the screen rectangle. And to do that, we'll have to create a little array here. So we will do a little points array here. So screen points, we'll do it like that. And we'll just manually write this in, like in here. Or we could actually do it at the top of, like we can do it at the top of the screen as well. And in fact, we could actually just use one thing. So let's actually go to the definition of screen rect. And instead of making it a rectangle, we'll make it a list of points that wraps around. So let's do, we'll call it screen rect, because it is a screen rectangle. But instead, we will set it up with the points like this. So the first point will be 0. So that will be the top left corner. And then the next point will be like this. Can we do it this way? You don't know, but I'll just do it like that. So the next point will be still on the x-axis, but it'll be on the other side. So get screen width, and that'll be 0. And now we have to do the bottom 2 corners. So vector here, vector 2. Here we'll do 0, or sorry, get screen width. So this will be, or does it go? I think it goes counterclockwise. So let's actually do it how the way that Rayla wants us to do it. So this would actually be 0 here. So this will be it'll start from the top left corner and it'll go to the bottom left corner. Right, and then we will. Why is it freezing? Why is this freezing? It's so annoying. Okay, get screen width, or actually, yeah, get screen width. So now with going to the other side, get screen height, right? And let's actually put these on different lines just so it's a little clear what we're doing here. And here we'll do another vector. Get screen width. And now we're back at 0. So this goes all the way around like that. Oh, there we go. And now we have to copy this point down here as well, because it has to close the polygon. There we go. Okay, so let's delete this now, because that's not useful anymore. And then we will go to update asteroid, or asteroid update, okay. And here we will do this check. So instead of check collision, we'll do check collision point poly. There we go. So that's going to check if inside, but it's at this point is inside the screen rect, and this has 5 points, so that should be good enough. And now we have to actually go through all the edges of our asteroid and see if it intersects any of the edges for the screen. So let's not point. This is point. After this, we'll be finished up. Perfect. I think we're going to be able to do this. So let's now get, this has to be -1. And now we have to check the, what's it called? If any of the lines intersect. So we actually have to go through the screen position as well. So we'll just call it S I -5, 4, and this will be, oops, and this is not I, this is, that's an oopsie whoopsies. X minus is less than 4, and then we do well, I guess we'll do here, we'll do, instead of size of 5, we'll do size of 2. That should be better. Divided by 0. And here we will set the, how about we actually, you could set this near the what we define as screen rect size. So let's go up here. I don't know why it teleported me there. I'm going to screen rect. It should be really easy to figure out where that symbol is. So when the when that doesn't do it, it's kind of annoying. So here's screen rect, so let's do that. Let's make it an integer. Screen rect points, that's going to be equal to size of screen rect divided by size of screen rect, the first point in there. That should be good. Update, and now let's continue with this here. So instead of it's here, we will do screen rect points. There we go. And here we will do screen rect points -1, and we will do SS. Okay, so now that we have that set up, we have to check for the collisions for all those lines. So we'll set up a point, a P1 here. So this will be P, or let's call this A1. This will be asteroid points P. Copy this. Call this B1, and this is a +1 here. Copy these guys, put it down here. This is going to be A2. A2. This is going to be S and S+1. And now we'll finally check if there's a collision between these lines. So if check collision lines, we will put in here A1 to B1, A2 to B2. Like that. And we'll also put in the collision point. So let's set that here. Vector 2, collision point, and we'll set that down here. Collision point. And here what we'll do is have edges intersect screen rec, we'll set that through. And then we will break. And then we'll also break from this loop here. So if edges intersect if they intersect the screen rec, then we'll also break here. There we go. So once we break those two, we'll be out of that loop. We also have to make sure that this is, oops. We also have to make sure that, well, this should all probably go into a function, and we'll probably do that next video. I'll put this in a to-do. So to-do, put this in a functions. So it's in function, so it's here. What's happening? Okay, so we'll put to do here. We'll probably solve all the to-dos in the next video. So this is wrong. This is not asteroid points. This is screen rect, and this is screen rect. So let's do screen rect. All right, so that's good. And then here we have to actually add the screen, the asteroid position. So asteroid position, and we'll do that down here as well. Add asteroid position. There we go. Okay. So now it should be okay. And what I'm gonna do now, real quick, is I'm going to go up here. I'm actually going to create a static variable, static Boolean variable called just once, I guess. And we're going to not spawn anything. So we can't have it. If we haven't done it once, then we can't do it. But if we have, then we'll set this to true. And this will make it just so one asteroid will spawn, so we can test this out better. Okay, so let's make builds and let's see. All right, so we're waiting for the first asteroid to enter. So now it should, so that entered just fine, but now it should wrap around. Now that it's in the entirety is inside the screen. So let's see. And it doesn't. So let's fix that. Let's see every to-do we have. It's just that. So, all right, let's go through this line by line and see where it's going wrong. So asteroid hasn't entered the screen. Oh, so after we finish this loop here, yeah, where's the edges? Yeah, after we finish this loop here and we leave, we actually set we have to actually set this. So as entered screen is equal to the edges do not intersect. So if we don't intersect any edges, then we've entered the screen and then we're good. We don't have to call this anymore. So let's try it with that. So first we'll see if the asteroid enters. And it doesn't, so something's wrong. Let me do that one more time just in case it's like, oh, okay, so now it enters, because I think it just did not, it was probably like off screen or something. So we'll make sure that the asteroids enter, and this should now, there we go. So now we're properly, now it's properly like like it enters the screen completely first, and then it leaves the before, yeah, and then it, yeah, it's entered the screen first before we start like wrapping it around. So that's pretty nice. So you won't have popping in, we won't have asteroids just popping in randomly. The slow motion is so cool. I don't know why. Look at this slow motion. And then we're back to fast motion. So now we have asteroids properly wrapping. So let me remove that once code. Let's go, I think I called it once. Let's remove that. And where else do I need to remove it? I have to remove it here. So remove it here. And remove it here. Okay. And now the spawn seconds. So let's actually make the spawn time a little bit more. So let's make it 2 seconds instead. That should be better. Let's see how that looks now. Cool. So, okay, so that entered in just fine. So this is entering in. And now, yeah, now they wrap properly. So, yeah. The issue is that it could leave the screen before it starts wrapping. And so, like, it could be on the edge of the screen and then just leave and then just never come back inside the screen and never wrap. So, if that happens, we have to do, like, a fail-safe for it. Because we could have just random... We can just have random, like, asteroids floating around in the abyss that we're just not keeping track of. Let's do that again. Okay, so that entered in just fine. All we have to do is guarantee that the asteroids come into the screen. So this one here, for example, is just never... Oh, well, it's because it bumped. But that one, for example, if it left the screen, it would have never come back. Like, it would have never been part of the screen. And now this works really well. This is cool. It's really interesting how I need to do a better spawning of like the smaller asteroids, so they what's it called? So they don't like look like, so if I shoot this, you see it could have kind of stuck together. I just have to make them spread out more, I think, when I spawn them. This is also, yeah, that's also a big asteroid. What's cool about this is that I can, if let's say I'm having trouble, I can do a little, well, I'm gonna die here because this is so cool. The slow motion, it's so cool. Slow motion. The slow motion thing is just a random thing that I added. It literally took like a minute, I think, which is cool. Or like not a minute, like 5 minutes. But that's awesome. A little slow motion. Whoa. Uh-oh. This is 1/10 the speed that it's supposed to be going at. There you go. This is funny. And like, oh no, I'm getting into trouble. Slow motion it up and then try to do something else. Oh, I hear I'm gonna barely miss it, or am I gonna die? Yeah, I died. Cool. Alright, so that's pretty much everything I wanted to do this stream. Let's go to our to-do list, and as we can see here, we have better movement here. We have better the thruster and the laser fuel the particle spawn for a better position. The asteroids wrap better, and yeah, so that's pretty much everything I wanted to do today. Awesome. All right, so thank you for watching, guys. Thank you for coming into the stream and checking it out. Next time we will continue with working on asteroids in C. I think we'll probably start adding like different types of weapons, start like actually trying to polish it up and make a slightly better game every single time. All right, so thank you for watching. I'll see you guys tomorrow with the, is today Wednesday? I totally forget. I think it is, right? It's today Wednesday, yeah. So I'll see you guys tomorrow for the last stream of the week, and then we'll see what we do. All right, have a good night, guys.